Question on homework. Anything over tangent, secant, cosecant, cotangent? Yes, ma'am. Write the equations for the other ones. Got to narrow that down a little bit. Write the equations for the other ones. Like, do what now? Oh. So, which of the following is a vertical asymptote? So, I wanted the vertical asymptote for 1/2 x, right? Whichever one was the right answer. And then whichever one it was, give me the equation for, or give me a vertical asymptote at 0, which is like cotangent. Cotangent has a vertical asymptote at 0 because that is where cotangent is cosine over sine, and that's where sine is 0. That kind of makes sense? So this one should have been cotangent x. That's all I needed. I mean, there's more than one answer. There's more than one answer. It's to the point, guys. I'll be honest with you. When you have multiple choice on these homeworks, I don't know if you know it or not. I don't know if you know it or not. If you could circle the right ones by 1, looking at somebody else's paper, 2, guessing, 3, using your computer. I don't know. I have no idea if you really know it or not. So I have to start doing something to make sure that you know it. And so when there's multiple choice questions, I got to get something on there so that I know that you know it. Because we don't get any questions on homeworks because nobody asks questions on homeworks. Very seldom do they. And when they do ask questions, or when they don't ask questions on homework, and then there's not a very good scores on tests. So something's not correlating. Something's not correlating because every single question on the test was a homework question. Every one of them was. And so when I'm not getting questions on homeworks, I'm assuming everything is great, and it's not. So I've got to start doing something on homeworks to make sure that you just don't circle answers. I'm going to start just taking off multiple choices, just removing them all. I think it's good practice because typically when they're multiple choice on homework, they're multiple choice on the test, if that kind of makes sense. So, am I concerned that you don't have the other 4 or the other 3? No, not really. But I just got to have something on there besides a circled answer. I just got to have something. Yes, sir.
If you do number 4 on worksheet B,
I can do them all.
can you show me if it goes?
Number 4, worksheet B. Okay. We had some issues with this, or I had some showing you guys these questions. So you got cosec, or 3 cosecant squared x minus 1, and I got g of x is equal to 3. And the xy plane, where the coordinates of the plane intersections, where do f and g intersect from 0 to 2 pi? So what I would do is I would take 3 and then do cosecant, and it's squared x minus 1, and I would just say that is equal to 3. And then I'm going to add 1 to the other side because I got to get x by itself. So when I add 1 to the other side, I get 4, and then I'm going to divide it by 3. And so now I have cosecant squared x is equal to 4/3. And now I got to take the square root of both sides. And I know this is a little different because we haven't seen a cosecant squared. So understand this. They won't write it. This is different than that. Those two things are two different statements. This one, only the x is squared. This is the same thing as that. there's 2 cosecants and there's 2 x's. Okay, so I can understand why this, because we haven't covered this. So whenever you see a trig identity or trig function and it's squared, not the x, then basically the whole thing is squared. Basically the whole thing is squared. Great, I'm glad you asked this, because I didn't know that this was even on there. Different than this, because on this one only the x is squared. Only the x is squared. So we're taking cosecant of plain old x squared. Okay, so when I take the square root of both sides, I'll get the square root of cosecant squared x, which is nothing more than cosecant x. And if I get the square root of 4/3, it's now 2/3, or 2 over this root 3. And now you got to think of when cosecant is 2 over root 3, or cosecant is sine, and sine is the reciprocal of cosecant. So if sine is a reciprocal, so cosecant of 2 root 3 is the same thing as sine root 3 2. And sine is root 3 over 2 at that one, which is 1626 1/3. So it's 1/3, but it also could be here, because it's going all the way from 0 to 2 pi, and it happens twice. So it happens here and it happens here. So that's 1/3. I'm sorry, 1626 1/3, and then 2/3. So x is equal to pi over 3 and 2 pi over 3. Good question, and I can see why you had no issues on that. Hit me. Oh, when you do positive and negative. Oh, man, I didn't think about that. Yeah, that's a good call, right? You do square root of something, you got plus or minus. Good call. Plus minus. This really, we'll do all this stuff later. We'll solve for trigonomic functions. We're going to solve for trigonomic functions, which is what we're doing right here. So just, we're leading you into that. So anytime you take the square root of something, you got to do the plus minus. So it also happens down here and down here. So 1 6 2 6 3 6 4 6 5 6 6 6 7 6 8 6 4 pi over 3. Nine, 6, 10, 6, 5 pi over 3. So all 4 of those are answers. Yes?
We also go over 3.
Okay, I haven't done with this one yet. You good, John?
Yeah.
Everybody else okay? I could, if you guys got that without a whole lot of help, I'm impressed. Because obviously I just missed it without help. Didn't do a good job covering that. Like I said, this leads us up, I don't know which section it is. We'll solve for trigonomic functions. We're going to solve for trigonomic functions on one of these. Can't be too much more because we don't have a whole lot left. That's not today. So everybody okay with that? So that one should have 4 answers. They restrict the domain because that's where you can do that plus k pi thing. They restrict the domain because it happens infinite a number of times. Because it happened that you can keep going, keep going, keep going, keep going, keep going. But they restrict the domain so you don't have to do that plus k pi thing. Again, that's more on the solving part. Okay, you said number 3. Two plus root 3 cotan and 1. We're going from 0 to 2 pi. We want the intersections of m and p. So 2 plus root 3 cotan x equals 1. Subtract 2, -1. divide by root 3. So cotan x is equal to -1 root 3. And these are not easy. I mean, hopefully you get them, do them enough to where you know where these are 1 over root 3 or root 3. It happens either at the 6th or the 3rds, right? It has to happen at the 6th or the 3rds, because that's the only way to get the root 3s. Because at the force, it's a 1. And at the main ones, it's either 0 or undefined. So it has to either happen at this one or this one. And cotangent is cosine over sine. And so I need whatever this is to simplify to 1 over root 3. Okay, first of all, it has to happen in quadrant. I got this in quadrant 1. It's not quadrant 1 because it's negative. Because it's negative, it has to be in quadrant 2 and quadrant 4. That's where we're negative, because sine is positive, but cosine is negative. Sine is negative, but cosine is positive. So it has to happen in 2 and 4. And so to get 1 over root 3, let's see, it's either going to be, let me side note this over here. It's either going to be root 3 over 2 over 1/2, or it's going to be 1/2 over root 3 over 2. Has to be one of those. I mean, that's the only options it can be. And if I flip and multiply this one, the 2's cancel, and I'm just left with root 3. If I flip and multiply this one, I'm left with 1 over root 3. So this is the one I'm looking at. And remember that cotangent is cosine over sine. So I need cosine to be 1/2, and I need sine to be root 3 over 2. And that happens at the 3rds. Sine is more than cosine. So it happens, I got this wrong again. Let me change this to black. So it has to happen here and here. 1, 6, 2, 6, 3, 6, 4, 6, 4, 6, 4, 6, 4, 6, 2, pi 3, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6. X equals. X equals. I hopefully you guys kind of get the way I'm talking myself through that whole thing. That's kind of the way I would think. I don't have any of that stuff memorized. I don't. Just got sines and cosines. And it takes a lot of practice. Yep.
If you have the -1, how do you know which value is negative?
It doesn't matter. Right? If the top's negative, the bottom has to be positive. If the top's positive, the bottom has to be negative. One or the other. Good question. Y'all follow all that stuff. These are things I think you assume that you know. Ren, that's going to get you in trouble, bud. It's not going to get you in trouble. I'm not going to get you in trouble. Going to get you in trouble at home. Okay. I don't care. So I just talked myself through it. Okay. And you just have to do these enough. I know it's a shame that you have to actually do more than what you want to do, but if you don't do a lot of this, it doesn't come natural. It doesn't come easy. So you have to just talk yourself through all these. They're only going to give you the ones that you know. It's either going to be the 30s or the 45s or the 60. And I keep saying degrees because that makes more sense, but it has to be either that one, that one, that one, or the main ones. Has to be. They're not going to give you every one. If they don't, then it has to be a calculator question. Has to be. So and then if it's the force, that's where cotangent and tangent are ones. They're either ones or negative ones. Or positive ones, negative ones. Positive one, negative ones. So those are the easier ones. The 3rds are the ones that are the hardest, or the 6th. And it can only be the sixth, 1/6 or the 2/6. And it depends on if it's 1 over the root 3 or root 3 by itself. And again, it depends on if you're talking tangent or cotangent. So I just solved it. I had 1 over root 3, so I knew it had to be here or it had to be here. I knew that cotangent is cosine over sine. So then I just side noted over there and I said, well, I need either one of them to be 1/2 and the other one to be root 3 over 2. And so I just figured out which one simplified to that. And you just have to talk yourself through the entire process of it. Or memorize it, but if you memorize it wrong or you guess wrong, I would rather go through it like that, working it, knowing you got it right, as opposed to having it memorized. Now again, we'll have it, after doing them so long, you'll start noticing, you'll know which ones are root 3s and which ones are 1s over root 3s. I mean, after you do them so long. Good questions. Again, I would understand why you would have some issues with this stuff, because I didn't do the greatest job at all teaching you guys this. Negative instructional on that. I gave myself an F-. I tried to graph it for some stupid reason. I guess because we were talking about graphing. Okay, what else, ladies and gentlemen? Anything else over worksheet A, worksheet B? And then we had the calculator ones. Hopefully you got calculator practice. The reason why they have all that is because that's like test type question. You'll have your calculator. You got to have two. And Desmos actually works a whole lot better than your TI does on these. It really does. If you're going to use your TI, I would set my window from 0 to 2 pi. So you have set your window. No telling what mine looks like. I think it has a zoom trig. It does have a zoom trig. But I don't know what those values are. That's not 2 pi. So I would go from 0 to 2 pi. 2 pi. Whoops, that's not pi. This is pi. And whatever, who cares what the scale is? And your Y min and your Y max is 4, and that's probably perfectly fine. If you're setting it equal to 0. If you're not setting it equal to 0, then your Y max and your Y min needs to be the other function. Holy cow. I need to eat something. My tummy just told me I need to eat. You know, if you got F and G's 27, then you need to change that. But I just moved the 27 over and set it equal to 0. And so then when you graph it, now you'll see 0 to 2 pi. And you got to put your Y function in there, turn these plots off. Desmos does a little bit better job of it. Little bit better job. It's easier to find the intersection on Desmos because you don't have to do left, right, guess. You can just move that cursor there in order. I think it goes right to it. Okay. Anything else over 311? Whoops. Wrong one. This one. Okay, 3, 9. 3, 9 notes. 3, 9 notes. Didn't work. Come on. 3-9 notes. Quick, short notes. Boy, it tests your knowledge, though. Test your mathematical knowledge. Inverse trigs. Inverse trig. We did inverses for logarithms. We did inverses for functions. We did inverses for polynomials. Some inverses, think back, right? Some inverses are not functions. Sine and cosines inverses are not functions. They're not. Bless. Because of the horizontal line. Like you'll have 2y's for 1x. You have 2y's for 1x, so when you flip it, you got 2x's for 1y. Remember, inverses, all you're doing is flipping x's and y's. You're flipping x's and y's. And if you keep that in your head, every time you see inverse, you're thinking, okay, my new x is my old y, and my new y is my old x. You just flipped x's and y's. That's all we did. As with all functions, the inverse of trigonomic functions result in the switching of the input and the outputs. As a result, the output functions of the trigonomic functions is going to be an angle. We used to input an angle and get a value. Now we're inputting a value and getting an angle. Notation. We can represent inverse trigonomic functions in two different ways. The way that you guys are used to seeing inverses. Sine to the negative 1x. That's the way you guys are used to seeing inverses. Y to the negative 1. F to the negative 1 of x. That's the way you're used to seeing it. Trigonomic likes to put an arc sign. Arc cosine. Arctan. They put the word arc in front of it. You may see it either way in AP. So you need to recognize that if you see the negative 1, that's the inverse. And if you see the word arc, it's an inverse. You could see it either way. So sine, inverse, that's the one that you guys are used to seeing. I don't think that one's that uncommon. Or arc sine, just ARC. And it could be arc cosine, arc tan, arc cosecant, arc secant, any one of those. Okay? Write the statement, sine pi over 6 equals 1/2 in an equivalent form using arc sine notation. So they want me to use arc sine notation. So I'm simply going to write. Let's see, this is sine of pi over 6 is 1/2. They shouldn't tell me it's 1/2. You should know that that's 1/2. 1/2, we just fall a little bit, okay? The way we're going to write it is arc sine, and now I'm putting the value. Arc sine of 1/2 is equal to pi over 6. Whenever we have the inverse or the arc sine, it's always equal to an angle. It's equal. I'm looking for an angle. When you see the arc, you're looking for an angle. When you guys did SOHCAHTOA stuff, you did arc sines. You did sine inverse. You moved the sine to the other side and you did the inverse. You hit second sine to find the angle. We're finding the angle. Okay. Notation. That's all we talked about so far. Notation, words. This stuff, you already know inverses. Inverses, flip them. You got to remember that. Okay, because trigonomic functions are periodic, we have to restrict their domains. We have to restrict their domains so that the inverses are a function. Restrict their domains so that the inverses are a function, because they're not a function when they go infinity to infinity because the horizontal line hits them twice. So here's what you need to know. Whoops, already had that. In order to make the inverse function, we're going to restrict the function sine. Sine is going to go from negative pi over 2 to positive pi over 2. You have to know this. You just have to know this. You do know something already. You do know that if I have the unit circle and I have any value in quadrant 1, that's a horrible circle. Any value in quadrant 1, whatever the sign is, you also have a value over here. Sine is 1/2 here, sine is 1/2 here. Sine is negative 1/2 here and negative 1/2 here. They're going to restrict the domain for sine here. So all my angles will either be in quadrant 1 or quadrant 4. They will be in quadrant 1 or quadrant 4, and the quadrant 4 will not be all the way around because your domain is only from negative pi over 2 to positive pi over 2. This is positive pi over 2. Here's negative pi over 2. So your angles for sine will never be over here in quadrant 3. They'll never be over here in, I said 2 or 3. They'll never be in 2 or 3. When they are in 4, they're not going to be all the way around to 4. It's just going to be down to 4. Negative 1/3. It makes it nicer. It makes it easier. It's negative 1/3. I don't have to go all the way around and get 5, 6. 5, 6, 6, 6, 12, 6, 11, 6. 11, 6. Boom. Yay? Sine. Sine is restricted to negative pi over 2, pi over 2. Keep that in your heads. Cosine is going to be restricted to 0 to pi. Cosine is going to be restricted to 0 to pi. Again, unit circle. We can't restrict cosine from negative pi over 2 to pi over 2 because cosine's all positive here. All of those are positive angles. So I'm not going to restrict it from here to here. I'm just going to restrict it from here to here, which that one almost makes sense. So I'm going to restrict it to quadrant 1 and quadrant 2 only. Only. And the reason why is because it repeats itself. And so I could have answers down here or down here, but then I don't have a function anymore. So they're going to restrict the domain from 0 to pi. Tangent is the same as sine. Tangent is the same as sine. We're only doing these 3. However, cotangent is the same as this one. Cosecant is the same as sine, and secant is the same as cosine because they're just reciprocals. Beat that in your head somehow. Sine and tangent are quadrants 1 and quadrants 4. Cosine is quadrant 1 and quadrant 2. Positive, negative, positive, negative, positive, negative. Cosine's not positive, negative. Cosine's positive, positive, so it wouldn't make sense to go 1 and 4. So they're going to go 1 and 2 for cosine. I'm not going to go 1 and 2 for sine because they're both positive. So I'm going to go 1 and 4. Why don't I do 3? Because that just doesn't make sense to go 1 and 3. They're not connected. Yay. Okay, get it through your heads. Here's where they're also talking about that same thing. Sine, quadrant 1, quadrant 4. Sine, quadrant 1, quadrant 4. Negative pi over 2 to positive pi over 2. Negative pi over 2 to positive pi over 2. Cosine is only going from 0 to pi. 0 to pi. And tangent does the same thing as sine. Cotangent does the same thing as tangent. Cosecant does the same thing as sine. And secant does the same thing as cosine. However, they don't deal a whole lot with the reciprocal functions. Basically, unit circle questions right here, guys. Unit circle questions. Cosine inverse, negative root 2 over 2. Cosine inverse, root 2 over 2. Happens at the force. If you have to, draw it. However, cosine is not defined down here or down here. So root 2 over 2 is 1/4, 2/4, or 3/4. And I want negative. So it has to be negative plus 3 pi over 4. Negative 3 pi over 4. You're looking for the angle. You're looking for an angle. Anytime you see that inverse, just get it in your head. You're looking for an angle. Yes? Because of that. Huh? What? Oh, I didn't mean to put that. I'm sorry. Now I see your question. I didn't mean to put negative 3 pi over 4. I don't know why I did. 3 pi over 4. 1/4, 2/4, 3/4. Negative 3 pi over 4 is 1/4, 2/4, 3/4. That's quadrant 3, and it's not defined in quadrant 3. It's not defined in quadrant 3. Cosine's only defined in quadrants 1 and quadrants 2. So there should never be an angle in 3 or 4 for cosine. Sine, root 3 over 2, negative. Sine is only defined in quadrants 1 and quadrants 4. If it's negative, I need quadrant 4. Quadrant 4. And sine is the big one, because it's root 3 over 2. It's not the 1/2. And so this is 1/6. That's the 2/6. It's negative. This one is negative pi over 3. That really felt good. Yep. You will not get in trouble. You will just get it wrong, because it's not defined for 5 pi over 3. Y'all hear his question, right? His question? If I wanted to put 5 pi over 3, it's not defined for 5 pi over 3. It's only defined from negative pi over 2 to positive pi over 2. Negative 5 pi or 5 pi over 3 does not fit that. It's too big. So you'll never have an angle for sine bigger than pi over 2 or smaller than negative pi over 2. Oh, stupid tangent. Root 3. Root 3. That either happens at 1/2 over root 3 over 2, or it happens at root 3 over 2 over 1/2, which is that one. It happens at root 3 over 2 over 1/2. Sine, cosine, sine, cosine, sine, cosine, sine, cosine. Pi over 3. However you got to do that. Talk yourself through it. However, you'll start to get the tangents down a little bit. Last question. Example number 2. Is that it is last? Recognize one of these? Yes? Seen one of these already several times? You have a unit circle, or you have a circle. It may not be unit. You have a P right here that says X, Y. You have a Q over here, you have an R over here, and you have an S over here. It is unit because it says 1, 0. If this is P, X, Y, then this has to be negative X, positive Y. This has to be positive X, negative Y. This has to be negative X, negative Y, and they're telling you all this stuff. The angle theta is in standard position. The terminal ray intersects the unit circle at point P, whose coordinates are X, Y. Points Q, R, and S are the results of the terminal ray being reflected over the Y-axis, the origin, the X-axis. They're just basically telling you they're exact mirror images. Just making sure you know that. For each of the following expressions, determine which labeled point intersects the terminal ray of the given angles. Be familiar with all that statement. Don't let it confuse you a whole lot, because I mean this is AP question. AP question. Cosine inverse X. cosine inverse x has to be in quadrant 1 because it's positive, which is simply point P. Point P. Cosine inverse x. The only other thing they could possibly put there is cosine inverse of negative x. They can't put cosine of y because there's no such thing as cosine y. There's no such thing as sine x. Can't. Sine negative y. Sine is negative in quadrants 3 and quadrants 4, but the inverse is not defined for quadrant 3. It's only defined for quadrant 4. And quadrant 4 is S. Cosine negative x. Cosine negative is in quadrants 2 or quadrants 3, but cosine's not defined for quadrant 3. Cosine's only defined for quadrant 2, and quadrant 2 is, was it Q? Q. Q. Tangent negative y over x. Tangent cannot be x over y. Tangent can only be y over x because tangent's opposite over adjacent. It's sine over cosine. Negative can only happen in quadrant 1 or quadrant, well, tangent can only happen in quadrant 1 or quadrant 4. That has to be quadrant 4. S. Easy peasy lemon squeezy. Sweet. Y'all ready? Something special. Oh no. Homework, you get to use your friends and your notes and all kinds of other stuff. I want to know what you know. What you know.
Homework on our computer. When's the flex routine?
Well, I asked for any questions before class started, and we didn't have any. The 2 questions we had, I covered. That was it. I figured if you don't have to ask any questions, everybody's got to know it. Did y'all see, y'all got your grades in the, did I put grades in the grade book on the last test? I put the raw.